In this video I'm going to show how to assemble the heavy haul and loader that all the parts have been made for. So we'll start with a new assembly in Inventor, and inside that assembly I'm going to place the chassis . I'm going to rotate my view to the same orientation that it would be in the drawing and set that as the home view. And then also, if your settings do not have the first piece to be grounded by default, then you want to right click on it in the browser and make sure that it's grounded. That way that piece won't move around. Now I'll put the cab on top of the chassis. I made the cab as a single piece, so I have to find that. And place it in the drawing. Then I can assemble it with a few constraints. I can do a mate constraint for the bottom of the cab to the top of the chassis, and then flush constraints for the side, and also a flush constraint to the back. However, it's not 100% flush constraint because it is 1 3/4 of an inch from the back. So I'll add a 1 3/4 inch offset, and that will place it where it needs to be. Next I'll attach the hood. According to the plan, the small hole in the hood goes towards the back, and there are 5/16 of an inch gap along the side, and it's flush, or it's mated to the back of the cab. So I will place a mate constraint on the bottom, onto the cab, onto the chassis, onto the back and onto the chassis, and then a flush constraint with the side that's offset at 5/16 of an inch. If it goes the wrong direction, you simply can change that positive value to a negative value, and it'll place it where you need it to be. And then rotating around to the front where the support goes. That support goes on the front, centered there, offset by 1/2 inch, and flush with both the front and mated to the cab. And a 1/2 inch offset here. Next I'm going to place axles and wheels into the chassis. So I'll get 2 copies of my axle. For this I'm going to use an insert constraint. An insert can either be opposed or aligned. I'm going to want aligned for this one, and it aligns 2 circular features along their central axis. So for instance, this circular feature is the end of the axle, and then the circular feature, the hole, it will align those along the axis. However, it's too far. We need it to stick out on both sides the same amount. So looking at the diagram, the chassis is 2 1/8 inch wide, and the dowels are 2 11/16 inch long. So the difference between those two values divided by 2 will give a 1/2 of an exposure on either side. So 2 11/16 minus 2 1/8 is 9/16, and 1/2 of 9/16 is 9/32. So I'll simply put in the value 9/32. If it goes in further than out, I simply need to put a negative in front of it. And that worked. Same for the other axle, and a negative 9/30 seconds. Now it's hard to tell because there's all one color here, but these axles are now constrained along the axis, but they can still turn about that axis. Now we'll do wheels. I need the wheel 4 times. And I'm going to use an insert constraint once again. You have to be careful though with something like the wheel to make sure you're choosing the right circular feature to align. So I'm going to choose this circle which makes up the inside of the hub and then the end of the axle here. However, for this one, again, I don't want an opposed, I want an aligned constraint. I'll do the same for the other 3. Now I'm placing the buttons onto the wheels, which act like hubs. They are assembled with inserts as well. I've done 3 of them already. This time, however, it is an opposed insert constraint. And it's as if you were gluing these buttons right onto the ends of the axles. So I'm choosing the circular feature, that's the bottom of the button, and then I'm choosing the circular feature that's the end of the axle or the center of the wheel. Either one actually would work. And that will align it right where it's supposed to be. Now I have the main body of the loader done. The bucket is the next thing. However, as the drawings show here, I'm going to, instead of assembling it all at one time, I'm going to assemble the bucket as its own assembly and then bring it in and assemble it with the rest of the loader. So I will create a new assembly. And in here I'll start with the back of the bucket. Then I will place the bottom of the bucket. Looking at the assembled view, or looking at the directions for the bucket, note that the bottom extends to the bottom of the entire bucket, while the back extends to the bottom, while the bottom piece goes flush with the bottom of the back. So notice there's a chamfer on the front edge. I want to make sure that's facing the right direction. But then I will constrain the bottom of the back in this orientation to, or the bottom of the bottom, to this side of the back. Then a couple of align constraints will finish it up. Align the sides and align the bottoms. Now 2 copies of the bucket side. These can be assembled with mate constraints and flush constraints. And then the bucket arms, I need 2 of those. Now I can start with a mate constraint to the back, but then I need to figure out where I'm going to constrain them. On the diagram, we can see that they are 1 1/8 inch apart, and they are 15/16 from the end of the back to the inside of the face. They are also 1/4 inch down from the top. So I'm going to use that 15/16 measurement. It will be a mate measurement from the inside of an arm to the end of the back. Now it's a little bit hard to select the back here. One way to do it is to get really close here and get this little triangle that's showing. But now it's mated there, and I need that offset of 15/16. If it goes the wrong direction, as always, I'll put a negative in front of it. And then I need it to be 1/4 inch down from the top. I'll do that with another mate constraint from the top, but this time I'm just going to select the top edge of the lift arm here. Then I can set it at 1/4 inch down from that. I'm just realizing that I did not constrain my first piece, so I'm going to go back in here to the back and ground that. Now the other piece I can do the same way for the bucket arm. A mate from the inside to the outside edge of the back. Another way to select the outside edge of the back is to hover over where it would be in space and then right click and choose Select Other. And that allows me a drop down here to choose different faces, and the one I want here is face 3. An offset of -15/16, and then a mate from the top edge to the top of the lift arm of -0.25. Now the arms are fully constrained. So I can save that as bucket assembly. And then in my other assembly, I can insert this bucket assembly as a part, or as something to be assembled. So I go to Place, and now choose my bucket assembly and place it into the model. And I'm going to use another insert constraint. I'm going to use the inside edge here of this hole to the hole on the support here. And that places it right in place. It is fully locked in place, however, we're still missing one thing to assemble. The pin that goes through here. So I will place a bucket pin into the model and then use an insert constraint to put it in the hole, and that part is in. And almost forgot one or two last things, the smokestack and the button on the hood. So I will go and place both of those in. For this I'm going to choose with an insert constraint the bottom of the button and the bottom of the hole, and same for the stack. And now the loader. Oop, not quite fully assembled. One more thing. The lift bar on the loader, on the bucket. So I'm going to go back into the bucket assembly and I'm going to place the lift bar in. Can assemble this with an insert constraint to the bottom of the hole. And when it goes in, it may look like it's fully secured, but if I grab it, I can actually pivot it out of place. So I need to use a second constraint to get it in. Now if you didn't get everything exactly right for the dimensions of the lift bar or where the placement of these lift arms go, that won't work. It'll give an error. So if you do have an error, that's probably what the problem is. Now I should be able to save this, and it should update in my other assembly. And there it is. So that's the fully assembled loader.